All right, so we are going to wrap up Unit 3 with this last section, which is writing angle proofs. Now, angle proofs is going to be very similar to what we did in the last section with segment proofs. So before we get started, let's remind ourselves of a few definitions that will pop up in a lot of our proofs today. So first we have angle bisector. Okay, so the angle bisector, basically, if I have one great big angle, and then I have a ray that cuts into this angle. So in this case, our ray is ray BD, and it cuts into this angle in such a way that it cuts this angle in half. Then the two halves are going to be equal to one another. So angles ABD, this top part, is equal to angle DBC. That's the definition of an angle bisector. Okay, next up is the definition of an angle, or the angle addition postulate. So similar to the segment addition postulate, the angle addition postulate tells me that if I have one great big angle, in this case my great big angle is angle XYZ, and I cut it into two smaller angles, angles 1 and angles 2, not necessarily cutting it in half, just cutting it into two pieces, then the measures of these two angles added together will equal the measure of my whole. So that's the angle addition postulate. Next up is the definition of complementary angles. So complementary angles are going to be two angles that add up to equal 90 degrees. Now, these two angles don't necessarily have to be touching one another as they are in this picture, but the idea of complementary angles is that if you were to push them together, this is what it would look like. It would make a 90-degree angle. And supplementary angles. So supplementary, similar to complementary. Supplementary is two angles that when added together have to equal 180 degrees. So again, doesn't necessarily have to be two angles that are touching one another, just if you were to push them together, they would make a straight angle. Okay, so that's just a few definitions. Let's get into looking at the proofs. Okay, so page 1. Show that if the measure of angle FAN and the measure of angle PET, show that if the measure of FAN is equal to the measure of PET and the measure of angle 2 is equal to the measure of angle 3, then we need to show that the measure of angle 1 is equal to the measure of angle 4. So they give us the statements, we fill in the reasons for this one, okay? So our first statement is always going to be everything in between the if and the then. So in this case, it was two statements. Angle FAN was equal to angle PET, and angle 2 was equal to angle 3. That was given to us. So the next statement they gave us was angle 1 plus angle 2 equals angle FAN. Angle 3 plus angle 4 is equal to angle PET. So at first, I'm not really sure where they're getting these angles 1 and 4. I've seen 2 and 3 before, so let's go over to a picture. So in our picture, we see angles 1 and angles 2, and we see that they are both two pieces of the whole thing, which is angle FAN. So that makes sense for this statement for angle 1 plus angle 2 to equal angle FAN. Same thing over here, angle 3 and angle 4, they're two smaller pieces of the big angle, angle PET. So the reason why we got these two statements was by using the angle addition postulate, which I just abbreviated to AAP. So next up, angle 1 plus angle 2 is equal to angle 3 plus angle 4. Well, I've seen angle 1 plus angle 2 up here. I've seen angle 3 plus angle 4 up here. But I don't know where they come together. How is it that they're being able to set equal to one another? Well, if I look back to my very first statement, it told me that angle FAN is equal to angle PET. And then right here in my second step, I'm given a further definition of angle FAN and angle PET. So all they did here was they took this first half of my first statement and rewrote it down here using what we learned here. So this angle 1 plus angle 2 is my angle FAN. This angle 3 plus angle 4 is my angle PET. So all they did was they took this statement and rewrote it down here and substituted in the values for FAN and PET that we found right there. So we got that one by using substitution. Next one. So angle 1 plus angle 3 is equal to angle 3 plus angle 4. So the only thing that changed from here to here was that they switched out angle 2 for angle 3. But how is it they were able to do that? Well, we just look back at the very beginning, because in the very beginning we were given two statements, and the second one said that the measure of angle 2 is equal to the measure of angle 3. So that means anywhere that an angle 2 pops up, I can switch it out for angle 3. So that's all they did here. They took angle 2, swapped it out for angle 3 by using the substitution property. Okay, and lastly, the thing that I was trying to get in the very end was angle 1 is equal to angle 4. So we had an angle 3 on both sides of equal sign. So I just subtracted the angle 3's from both sides, got rid of them, and I was left with angle 1 is equal to angle 4. And I have that statement from using the subtraction property. All right, let's look at page 2. So page 2, show that if angle 1 is complementary to angle 2 and angle 2 is complementary to angle 3, then measure 1 is equal to measure of angle 3. So first up, everything between if and the then is my very first statement. So angle 1 is complementary to angle 2. Angle 2 is complementary to angle 3. That is given to us. Okay, next up. Angle 1 plus angle 2 equals 90. Angle 2 plus angle 3 equals 90. Well, if we remind ourselves what it means for two angles equal to 90, we know that that is just a definition of two complementary angles. So just using what we were given in the beginning, we just took that a little bit further and said that because these are complementary to one another, it means that they will add up to equal 90 degrees. And we have that because of the definition of complementary angles. So next up, angle 1 plus angle 2 is equal to angle 2 plus angle 3. So with this one, if we've got up here that angle 1 plus angle 2 is equal to 90, and angle 2 plus angle 3 is equal to 90, so I've got two expressions right here that are equal to 90. So if they're both equal to 90, that means that they can also be set equal to one another. So that's why we wrote that right here. So basically all they did here was they just replaced it. So we just took this first statement, angle 1 plus angle 2 is equal to 90, and rewrote it. But for the 90, I replaced it with angle 2 plus angle 3. And that's all they did right here. They just used substitution property to replace that. And lastly, I want to get that angle 1 is equal to angle 3. So from up here, I need to get rid of these angle 2's. And the way to do that is to subtract them because they're added in at the moment. So I'm going to subtract the angle 2's from both sides. And I'm going to get angle 1 equals angle 3 by using subtraction property. All right, let's look at the next one. So page 3, we need to show, or we are given, that the measure of angle 1 plus the measure of angle 3 is equal to 180. And from having that information, we need to prove that the measure of angle 1 is equal to the measure of angle 2. Okay, so first up, my first statement, which we need to write in, is that angle 1 plus angle 3 is equal to 180. Again, if they give you a conditional statement, like an if-then statement, then you'll write everything between the if and the then in your first statement box. Otherwise, if they give it to you in this format, anything following the word given, you'll put right there. And your reason for having that statement is that it was given to you. Okay, so next up, angle 2 plus angle 3 is equal to 180. Okay, so we can see over here in our picture, angle 2 and angle 3, that those two angles, they form a linear pair, which a linear pair is just a pair of supplementary angles that are also adjacent to one another. So we know that angle 2 plus angle 3 is going to equal 180 just by the definition of supplementary. I accidentally wrote in something wrong there. Just ignore that. This is supposed to be definition of supplementary. Okay, so next up, angle 1 plus angle 3 is equal to angle 2 plus angle 3. Okay, so first statement said angle 1 plus angle 3 is equal to 180. Second statement said angle 2 plus angle 3 is equal to 180. So all they did here was they took this first statement and rewrote it down here. And then the 180, they substituted with angle 2 plus angle 3. Because we learned in the second step that angle 2 plus angle 3 equals 180. So that means that I can switch out 180 and angle 2 plus angle 3 at any time. So that's what they did here. And they used substitution property. And then lastly, I set out to prove that angle 1 is equal to angle 2. So right here, I'm just going to take the angle 3's and I'm going to subtract them from both sides and get rid of them. And I will be left with just angle 1 is equal to angle 2. And the way that I got that last statement was by using subtraction property. All right, we got two more proofs to look at. Let's look at page 4. So page 4 tells me that if IT, which is a ray, if IT bisects angle BIN, prove that the measure of angle BIN is equal to 2 times the measure of angle 2. So we start out by putting our first statement in here, okay? So our first statement will be IT bisecting BIN, and that's given to us. Okay, so next up they give us that angle 1 is equal to angle 2. And so if IT is bisecting this angle, that means it's cutting it into 2 equal parts. So in this case, the equal parts are angles 1 and angles 2. So angle 1 will equal angle 2 by the definition of a bisector, or you could put the definition of an angle bisector. Next up, angle BIN is equal to angle 1 plus angle 2. So angle BIN up here, that's my whole angle. And it's equal to angle 1 plus angle 2. So basically, one big angle cut into 2 pieces, add up the 2 pieces, they equal the whole. That's going to be the angle addition postulate. So that's how we'll have that statement. Next up, angle BIN is equal to angle 2 plus angle 2. Well, if we remember up here, the only difference from here to here is that they switched out angle 1 for angle 2. And so the way they were able to do that, if we look back up here, we already said that angle 1 is equal to angle 2. So I can switch out angle 1 anytime I see it and put in angle 2. So that's exactly what they did right here. So they got this fourth statement by using substitution property. And then lastly, we have angle BIN is equal to 2 times the measure of angle 2. So just like how we said at one point that the difference between doing addition property and combining like terms. So right here, again, imagine that we had x plus x, and if you were to bring those together, condense that into one term, you would get 2x. So here they have angle 2 plus angle 2. They have 2 of these, so they added them together, and they said 2 times one of those. And that's going to be combining like terms. And again, it's going to be combining like terms since we were adding these two together on the same side of the equal sign. Okay, so it'd only be addition or subtraction property if I had to add things or subtract things on both sides of the equal sign. But since here I was adding them together on the same side, we're going to consider that combining like terms. All right, and now the last proof. So prove that if the measure of angle 2 is equal to the measure of angle 3, then the measure of angle MOT is equal to the measure of angle BOP. So we start out with our first statement. Angle 2 is equal to angle 3. That's given to us. Next up, they tell me that the measure, angle MOT is equal to angle 2 plus angle 1, and angle BOP is equal to angle 1 plus angle 3. Well, if we look at our picture, angle MOT is equal to angle 2 plus angle 1. So that sounds like an angle addition postulate. And then angle BOP is equal to angle 1 plus angle 3. So that also sounds like angle addition postulate. So that's indeed how they got those statements. Okay, next up, angle MOT is equal to angle 3 plus angle 1. So it seems like they took this top statement and just rewrote it. But they changed one thing. They changed the angle 2 for angle 3. So the reason they were able to do that is because up here in our given statement, we learned that these two are equal to one another. So I can switch them out anytime I need to. So that's what they did right there by using substitution property. And then lastly, angle MOT is equal to angle BOP. Well, again, they just took this statement and rewrote it, or they just took this second half and substituted. We learned up here that angle BOP is equal to angle 1 plus angle 3. So angle 3 plus angle 1, that's the same thing by using commutative property. So all we did was just substitute that out. So we got our final answer of angle MOT is equal to angle BOP by using the substitution property.